Today we're going to be starting chapter 2 in your book, and most of what we're going to talk about in the first part of this chapter is completely review, although there will be a few things that come up that are new as well. This chapter deals with solving equations, and solving equations really is the single most important skill there is in algebra. When you are solving an equation, what we're trying to do is figure out what number is the one and only thing that will make an expression true. So if you had something, for example, like 2x plus 3 equals 17, hopefully it makes sense that 7 will give you a correct statement because 14 plus 3 equals 17. But any number you tried other than 7 will not work. And so our goal is to figure out, not just in equations like this, but in virtually any equation, how can you find that answer? You should know from things you've done before in junior high that you can solve equations by doing the opposite of what's already been done. If you've got a problem that says plus, you've got to subtract. If it says minus, you'd have to add to come up with an answer. And if the problem has multiplication, you divide. You always want to do opposites. The whole idea is you want things to cancel out. That's why we're doing the opposite of what's been done. And by doing that, what should be left is the x. When you do work with equations, what has to happen is you do the same thing to both sides of the equation. So like in this example, they subtracted 13 on both sides. Whatever I do to the left, I've got to do to the right. You can do that with adding and subtracting. You can do that with multiplication and division. The further you go in math, you're going to find there's more and more things that you can do to both sides of an equation, but it's got to be, like it says here, balanced. You've got to do the same thing on both sides of an equation. You can't just do it to one side and leave the other alone. So we're going to go through a bunch of examples today and hopefully make sure that you remember how to solve all of these different kinds of equations. What you might want to do is pause as we go through each of the examples, just kind of convince yourself in your mind that you know what's going on with things, and then make sure as I explain them that, yeah, you were right in what you were doing. So you want to think, how would you solve 7x minus 13 equals 50? And when I asked that in the regular class this morning, somebody piped right up and said, you add 13 and then you divide by 7. And that is exactly right. You've got to add 13 to both sides, you divide by 7, and we do indeed get an answer of 9. Now, a question that sometimes comes up when people are doing this is, do we have to show our work as we're going along? You can see here, I showed every little painful step of the work. And the honest answer is, it depends. If it's an easy problem like this and you can, in your head or even on a calculator, add 13 and then divide by 7, and you know the answer is 9, yeah, you can go ahead and just write down 9, that's fine. That's what I would do if I was solving it. On the other hand, the harder the problem gets, the more writing down work is going to help you get to solving that equation. But yeah, here we add 13, we divide by 7, and the final answer is 9. Our next one is negative 5x plus 7 equals 82. Again, think, what would you do? And hopefully you know you would subtract 7, and then you'd divide by negative 5, and we're going to get an answer of negative 15. You do want to be careful in a problem like this that if you have a negative number, you divide by a negative. And it's okay to get negative answers. You can get anything you want, but you want to make sure you don't lose negatives along the way. So in this problem, 4x plus 25 equals 13. Hopefully you know you're going to subtract 25 and then you divide by 4. And we do end up getting an answer of negative 3. Now, something that is important when you're solving equations is you want to make sure that you do things in the opposite of the order of operations. And that sometimes seems kind of weird when we just got done doing a test where order of operations was important. Here, because we're doing the opposites of everything, that includes the opposite of the order of operations. I always add or subtract first, then I multiply or divide. So again, you might want to pause the video and see if you can do these four problems and come up with an answer for them. And we do end up getting that A is 12, B is 4, C is 34, and D ends up being -9. When I was going through these in class, I had somebody that was concerned they had actually gotten on B that the answer should be -4. But if you think about it, on B, you would have to subtract 13. That'll give you -8. Then you do -8 divided by -2. Those negatives cancel, and that's why it's just plain 4. So here's 3 more questions that we'd like to see if you can come up with the answers for. And the difference this time is that all of these are problems that do not come out even. It's okay to have problems that don't come out even. In the real world, that happens all the time. If you have an answer that is a fraction, it's okay to write it as a fraction. It's okay to write it as a decimal. There's lots of ways you can write different answers. On that first one, you notice I put 58 fifths or 11.6. Someone this morning was asking, could I write 11 and 3/5? Sure you can. That's no problem at all. So any reasonable form of the answer is good. One thing I will caution you on is if you get something like the 1.3 repeating that I have at the bottom, you don't want to just write 1.3. If it's a repeating decimal, you want to say that because 1 and 3/10 is not the same as 1 and a third. And so, yeah, 1.3 repeating would be our answer. There are equations that are actually even easier than the ones we just did. In your book, they spend 2 whole sections just going through stuff like this, which hopefully, means that you just subtract or you just divide and you get easy answers. And I do have a dumb cartoon that I scanned where it says, just a darn minute. Yesterday you said x equals 2, and now x equals 3? Gee, what is up with that? And of course, the reason is x is a variable. It can stand for literally anything, and it changes between equations. So next I want you to take a minute and see if you can solve 17 equals 3x minus 7. If you did this right, you should have started by adding 7 and then dividing by 3, and you end up getting an answer of 8. This problem is written backwards from how we usually write equations, but there's nothing that says you can't do the same thing. In fact, if you don't like 17 equals 3x minus 7, you could just literally turn it around and say 3x minus 7 equals 17. It's the exact same problem. Again, take just a minute and see if you can solve 19 minus 2x equals 104. Of all the problems I have, this is probably the one people have the most trouble with among the relatively easy problems. What you want to do on this is to start by subtracting 19, and then you're going to divide by -2. The thing that people do wrong on this is they remember you're always supposed to do opposites, but they focus in on that big minus in the middle of the problem, and so they want to add something. They'll either add 2 or they'll add 19, and either way, you get a wrong answer. The number you want to get rid of is 19. It's positive, so we've got to subtract to cancel it out. and we do subtract 19, then divide by -2, negative 42 and a half will end up being the answer. Now, once you know the basic steps of what to do, it doesn't matter what the numbers look like, you can still come up with answers. So if you had a problem like 12x plus 1794 equals 2127, there's no reason to be intimidated by big numbers because you should know you've got to subtract and then divide, and you're going to come up with an answer, which here happens to be 27 and 3/4. Now, one thing I will caution you about if you are using a calculator is you want to make sure that you do this in 2 steps, that you do the subtraction, find out what that answer is, and then divide. Sometimes people try to just type in 2127 minus 1794 divided by 12 all in one big line. And what happens is the order of operations takes over and it just divides the second number by 12, not the whole difference there. So subtract in one step, then divide. And again, take a second and see if you can figure out this problem. 963 minus 25x equals 704. So this is another problem where the x is in the middle. And what you're going to want to do with that is to first of all subtract 963 and then divide by -25. And when you get done, you should have about 10.36. Now for this video, that's where I'm going to stop today because that's as far as we ended up getting in third period this morning. But it is a start on the main kinds of equations. There'll be a continuation where I talk about some other variations on solving equations, and then you'll have some problems where you need to do those things. So remember, you do opposites. If it says plus, you subtract. If it says minus, you are going to add. And then you divide by what's next to x.